Hello, everybody. Welcome to Python Lesson 4, Statistical Learning. So in the last session, which was Python Lesson 3, Pandas Part B, we saw that how we can import a data set. And we are going to import the data set again. So this is exactly like what we had before. I'm going to just run it. And I see that I'm getting error. It says name PD is not defined. Why? Because I forgot to run these, import all of these libraries. So every single session that you start Python, and you have to import these libraries again. So a few of them we are going to use later on. But right now, for example, we need this one, import pandas as PD. Again, with get os.get cwd, we get the directory. Make sure the directory is correct. Again, your computer's name is not going to be SSEZ1. It's another thing. You have to replace that right here and then run this. And I mean, only the first time, and then, but you have to do this the first time and then import, let's say, pandas as PD. And then later on, we are going to do a few other things, like let's say t-test and correlation coefficients and data visualization and regression. So we need to import these as well for later uses. And then we import this dataset df as this dataset scores as df. Yes. I asked Python to show me the head of df, and I see this is the head of df. Yes. And we talked about how to edit this file. For example, I changed for index 5 gender to M. It was by mistake male, and then changed the final example observation index 10 to 349. The name of observation index 25, and name is like column index 0 to Jessica. It was Jessenia. So we saw all of that before, and this is the data set after all the corrections. We saw we can just rename, we can round the data set like this, create a new variable called total, and then create a function here, and then apply that function. And then now we have this column grade. After that, we saw that we can rename this data set. We can rename column assignments to HW, which stands for homework. And if I ask Python to show me DF one more time, it just does shows me Python. So one thing that I want to mention is that if you have any, let's say, questions about what does this part of code mean? Can you explain this part of the code for me? Copy and paste the code, and then just go to ChatGPT. And all you got to do is this. Let's say, explain this Python code for me. And then hit enter. After that, just copy and paste everything, including the comments. You can do that, and then run it. And ChatGPT is going to explain everything like line by line in a very accurate way. So first, reading Excel file. The code begins by reading data from an Excel file named scores.xlsx located in specific directory desktop bus 202 data. It reads the data from sheet named sheet 1 into data frame df. DF head displays the first few rows of the data frame for inspection, and so on and so forth to the very end. Yes. And sometimes you can also, for example, ask, can you explain, can you elaborate? And then it explains even just a little bit more. Yes, in some cases, it describes what's happening with more details. Yes. For example, creating new variable, df total equals df assignments plus df exam 1, df exam 2, df exam 3 plus df final. This line creates a new column named total in data frame df, which combines the sum of scores of assignments as exam 1, exam 2, exam 3, and final score. Then the banana function, the banana num function is defined to assign a letter grade based on total score. Yes, and then you can always ask Python to just explain more. Yes, this is a wonderful tool that we have in our disposal, and we can always do this. So I encourage you to do that sometimes. Yes. Now that we have seen the changes that we wanted to make in this dataset DF and all the changes are done, now we can start statistical learning in Python. Okay, the first thing we want to learn is t-test. We use the t-test to test whether the means of two populations are statistically different or not. So essentially, we have two populations. Let's say the population of all professors in the United States. Let's say there are 100,000 professors in the US, and the population of all teachers in the United States. Let's say it's like 1 million teachers in the United States. Now, we can't go and ask, and we want to compare their incomes. Yes, how much they make in a year. We can't go and ask every 1 million teachers in the US that how much you make. So we rely on samples. So we take one sample from the population of professors. We take one random sample from the population of teachers. And now we got two random samples from each, like one random sample from each population. And based on that, based on the samples, we can take a look at the samples and we can judge the whole population. Based on the samples, we can judge if the means of two populations are equal or not. Of course, there is going to be a level of uncertainty because we don't have data on everybody. We took a random sample. But if our random samples are big enough, then with very high certainty we can judge if like means of two populations are equal or not. But we rely on t-tests. So we are going to run a hypothesis test that we have, let's say H0, which is means of population 1 equals mean of population 2, and H1, which is mean of population 1, is not equal mean of population 2. The output of the t-test is a p-value. P-value is a number between 0 and 1. If p-value is less than a significance level, which is usually 0.05, we reject H0 and conclude that the means of two populations are statistically different. So we are rejecting this, and if you reject this H0, it means you're saying means of two populations are statistically different. If p-value is greater than 0.05, we say we retain H0 and conclude that means of two populations are not statistically different. So essentially, we have to take one sample from each population and then run the t-test. So how do we do that? Essentially, if you want to, for example, run a t-test, you need only 4 lines of data. Let's start that with an example. Let's say we want to check if males and females have the same mean for final exam. Yes. So here there are 2 samples, sample 1 and sample 2. Sample 1 is just all the men, their final exam. I run this. Sample 2 is all the females, the score with for their final exam. So again, remember what exactly we are doing here. When you do only this part, df gender equals m, you run that part, you get a data set at all the males, yes? And then if you run everything up to here, you get all the final exam for the male students, yes? And then this part gives you all the female students. Yes, it's a subset of data set that includes all the female students. And if you run that data set, bracket final, you get all the finals for female students. So I got sample one, sample two, and then this statement is something that gives us p-value. This line, the p-value one, and the next line that we ask Python to display p-value, you can always just copy and paste them. Don't change it. You don't need to change anything. All you gotta do is to change this line, the right side of sample one, and the right side of sample two. That's all you gotta change. You can keep everything else as is. Yes, you don't have to change anything else. So with that being said, let's run everything here. So one more time, sample one, sample two, and then I run p-value, and then so now I see that p-value is created here. I ask Python what's the value for p-value, and it's 0.44. 0.44 is greater than 0.05. So whenever the p-value is greater than 0.05, you can always just copy and paste these two lines. You can say this, since p-value is greater than 0.05, we retain H0. Then usually the term for retain is also fail to reject, but essentially we are saying that mean of population 1 and mean of population 2, they are not different or they are equal. Yes, somehow you're saying that they are not statistically different. So like male and female students have done more or less the same on the final exam. Mean of these two populations are not uh, different. One thing that I want to mention is that obviously the mean of two samples. So if I do this, if I take a look at the mean of, for example, final exam for male students versus the mean of final exam for female students, yes? Obviously, these two are different, yes? For male students, the mean of final exam is 315. For female student, that's 302. So male students, on average, the mean is like around 13 units more than females. However, and I learned when I was 8 years old that 315 is greater than 302. So, but however, the problem is that here we are not comparing means of two samples. Obviously, 315, which is the mean for males, is greater than means for female, which is 302. But what I'm doing is that I want to compare if the means of two populations are the same or not, not two samples. Yes, that's the important point that we have. So this gives me the mean of, let's say, so if I ask what's the mean of sample one, what's the mean of sample two, that's the answer. And then we check if they have done the same on the population case, yes? Okay, so mean of final for male students, yes? That's the answer is this, which is 315.7. Yes, again, 315.7. And this one, mean of final for female students, For female student is going to be something like this. And if I run this, I can see that 302. So I'm not, however, comparing the means of two samples. Obviously, mean of sample for male is greater than for female. Here, if compare means of, so what we are doing, we are comparing means of male and female students in two populations. So I can rewrite this. Compare means of final exam for male and female students in two populations. So in samples, obviously men are doing better. In population, however, we concluded that they are almost the same, more or less the same. But the one that's related to, let's say, uh, t-test is only these 4 lines. Here, just be very careful. When you're doing the t-test, you do not need this mean. This is wrong. You can't have this. This is wrong. Don't do this. This is only gives you the sample mean, and this one gives you the sample mean for females. If you want to do the t-test, then you just don't need the dot mean. Yes. You get the sample one, you get the sample two, and then you get the p-value, and based on the p-value, you compare them. So that's how we do it, yes. Let's do one more example, yes. Let's say the question is this. For male students, what's the sample mean for male students' homework? That's one question. Another question is this. What's the sample mean for male students? Let's say exam 1. So if I want to do sample mean for male students homework, I say this df and then condition, which is df gender equals m, and then I say, let's say homework, and then I say dot mean. So that gives me the mean for 173. If I want for exam 1, I can just copy and paste this and change this HW to exam 1. So now I can see that for male students for exam 1, the mean is 173, and for homework 1, and then for exam 1 is 124.6. Now again, as always, I learned this when I was in like 8 years old, that 173 is greater than 124. So, but the question is to check if so from samples, we want to move to populations. We want to, based on the samples, judge the whole populations. Yes. How can we do that? So compare means of, let's say here we are doing, let's compare means of HW and exam 1 for male students in population, not in samples, but in population. So when you're doing the t-test and when you're comparing population, one more time, I'm repeating this, you do not need this dot mean. As a matter of fact, if you do this, it's going to be wrong. You can't do that, the t-test. Okay, so again, always you need just 4 lines of code. Line 1, sample 1 equals, each time just change right side of this. and then sample 2 equals, and then again change right side of this, and then two other lines that we have, p-value equals stats dot t-test underline ind, sample 1, sample 2, 1, and then p-value. Just copy and paste them. Don't change anything right there. So here, I can see that the p-value is 0.0002. I say this, since p-value is less than 0.05, we reject H0. Means of two populations are statistically different. Awesome. Now, as a practice, you do this. First of all, do this. What is sample mean for female students, HW, and then do the same thing for female students, exam 1. Just rather than HW exam 1. Yes, I want to see. So everything is going to be the same, but rather than male, we have female students. And then test if female students have the same mean for HW and exam in population. Yes. Okay, so please pause the video and do these questions right now. Okay, I hope you have done everything correctly, but essentially all you got to do is to copy and paste everything here and then change, let's say, male to female. So I'm going to change this M to F, this one as well. I'm going to just copy and paste everything here and then change M to F. And I'm going to run them. So here 169.4 for male students, for female students 133. Now I want to see if this gap between 169 and 133 is big enough that I can say, for example, two populations have done differently. So I'm going to just change this M to F and this one again to F. And I run this 4 lines. And I can see that p-value is 0.04. So you must add this to regression. Yes, say just p-value equals 0.04, sorry, 0.14. And then just copy and paste also these two. Since p-value is less than 0.05, we reject H0. Means of two populations are statistically different. Like students, female students have done statistically different on homework and exam 1. Perfect. That was just one last example and then one last, let's say, uh, study. So one last, let's say, question for you. If female and male have the same mean for exam 1 in population, yes, that's what we want to do. First of all, I want to see how they have done in the sample. Again, whenever you are moved, so first question is going to be this. What is sample mean for female students exam 1? So I'm going to just copy and paste this. What is sample mean for female students like exam 1? Yes. And then the same thing, I want to do this. What's the sample mean for male students exam 1? So to answer this, again, as always, start with DF bracket, inside bracket, condition. Condition is that gender must be here female. And then I want to focus on exam 1. And then I'm interested in its mean. So this is what I'm going to run. And then for male students, I'm going to just copy everything, paste it here. Oops. And then change that F to M and run it now. So students on average got, female students on average got 133 on exam one, and male students got 124. Now, matter of the fact is that I want to see if the gap, which is just 9 points, yes, around 9 points, is it big enough that I can say, I can claim like female students have done systematically better than male students? Or this is just happening by chance because of random sampling? For that, if I want to judge the whole population, I need the t-tests. So I'm going to do sample one, then sample two, and then p-value, and then this one. So again, the only things that I changed is here and here. Everything else is absolutely the same. P-value is 2.768. Since p-value is greater than 0.05, we retain H0. It means means of two populations are not statistically different. The gap between two samples are too small to say that females have done better than males. So it's not that big of a deal. And then last question, this is for yourself. So first means of, let's say, uh, females for exam two, please do this. Excuse me. And then same thing for male students exam two. So please do these two. And after that, run the t-test, see if they have done systematically different on exam two or not. So please pause the video now and answer these questions. Okay, I hope you have done everything correctly. What's the mean of female students for exam two? To be honest, all you got to do to copy this and then change exam one to exam two, yes? Or you can start from scratch, but it's just easier to copy and paste. So this is for female students. And then for male students, I'm going to just copy here everything and then do this and exam two. So again, this is not part of this part. Mean is looking at the means of samples is not part of t-test. Yes, I'm gonna write it here, maybe. Yes. So this is not part of t-test. So I've seen like many students confuse this part with the t-test, the actual t-test part. T-test is just right here. This is just comparing two samples. It gives us some insights about the difference between two samples. And then we do the t-test to talk about populations, yes? So again, here, this part is not part of a t-test. This is the t-test, yes? And again, this is not a part of t-test. And then this part is t-test. And the same thing here. I just want to make it very clear. Here we are not doing the t-test, yes? Here we are doing the t-test. And one last time, again, here we are not doing the t-test. The t-test is just right here. So I'm gonna, for t-test, I'm gonna copy and paste everything from here. And then, so this is the t-test. And then change exam one to exam two, because now the t-test is about exam two. And I'm gonna run everything and get the p-value. P-value is 0.23. Yes, and I'm gonna just write everything here, copy and paste everything from here again, and just change this to 2.3. And then again, the same thing here. Since p-value is greater than 0.05, we retain H0. Means of two populations are not statistically different. Awesome. The next topic that we have is for correlation coefficient. Correlation measures whether two variables move together. A zero correlation means that those two variables are unrelated to each other. A positive correlation means that the variables move in the same direction, and negative correlation means that the variables move in the opposite directions. And the syntax is very, very easy, yes? So the syntax is always like this, just something like this. So to have the syntax, so syntax is something like this. Pearson R, then variable one, comma, variable two, and then close the parentheses, and then in brackets 0, because it returns this Pearson R returns multiple items. We want to only focus on the 0 one, which is Pearson correlation coefficient. So this is the syntax. And Pearson correlation coefficient between x1 and x2 is something like this. So if I want to see if like correlation coefficient between exam 1 and exam 2 is how much, I just run this and I see it's like 0.45. Usually like students who do well on exam 1, they do well on exam 2. And there are some items in the world that they have negative correlation coefficients. For example, education and crime rates. Yes, the more educated people on average, they usually commit less crime. Sometimes two variables are like totally unrelated. Their correlation coefficient is usually like 0. And some variables are, for example, positively correlated, like exam 1 and exam 2. So as a practice, please do this. Pause the video and answer these two questions. What's the correlation coefficient between exam 1 and final exam? What's the correlation coefficient between exam 1 and exam, let's say, if you want, for example, we can do this. What's the correlation coefficient between men exam 1 and men exam 2? So same thing like here, but we want to focus only on men. Okay, pause the video and answer these two questions yourself. Okay, I hope you have done this correctly. The first one is very correct, very easy. I'm going to just copy and paste this, and then change exam to final. And I can see that correlation coefficient between exam 1 and final is 0.60. Great. And what's the correlation coefficient between men exam 1 and men exam 2? So it's going to be same syntax, yes. I'm going to write this Pearson R, open the parentheses, and then I need, let's say, variable 1. So variable 1 is going to be men exam 1. So it's going to be DF, and then condition, which is gender equals M. Yes. And then, so I have that condition. And then from that, so if I run this, I will get only male students, yes. But I'm interested only on the exam 1. So I'm going to say this and then exam 1. So by this, I can single out exam 1 for all male students. Yes, this is exam 1 for all male students. And then I want to compare that same thing, exam 2. So I can just copy and paste. And then I need the first element of this Pearson correlation coefficient. And if you run that, you get 0.2. So for male students, the correlation coefficient between exam 1 and exam 2 is 0.2. Great. Next topic that we have is data visualization. Data visualization is the creation of images or diagrams that communicate a data pattern in a highly readable format. So you want to usually create a graph, yes? For example, a histogram. Histogram is great for checking how the data is spread, the distribution of the data. For example, I want to see the histogram for total. Yes. So remember DF, the last column that we created was total. Yes. If we run DF, we see that this column total. I want to see this histogram for total. So I can run this and I can see this. And also I can see this right here in plots. Sometimes histogram doesn't show your plot here in the console, but you can click on this tab plots over right here, and it will show you that. So essentially, the format is this. For histogram, the syntax is going to be something like this: PLT, PLT, and again, PLT, we imported PLT at the beginning of the session. Like all of these things that we are using, like stats, we imported for t-test. We at the beginning of the session, we said from sci-fi import stats. And for Pearson correlation coefficient, we said from scipy.stats import Pearson R. For data visualization, we are saying import matplotlib.pyplot as PLT. So PLT means something to Python. That's a special 3 letters. Yes, it's not any 3 letters. Now the format, the syntax for histogram is something like this. All you gotta say is this plt dot hist and then column. Yes, column name or variable name. That's it. However, in many cases, we want to customize our histogram. For example, I want to have only 6 bins. I want the color of my histogram to be sky blue. Yes, or you can change it to anything that you want. You can make it, for example, red. You can make it like this is just blue. Yes, and then edge color. I want the edge colors to be just, let's say, black. So you can customize that. You can also customize it even more. Like, let's say we have 2 axes. We have x-axis and y-axis. I want the title for or label for x-axis to be values, the title for y-axis to be frequency, and then the whole graph I want to have the title of histogram or histogram underscore Azizi. Yes. So if I want that, all I have to do is to select everything here and then run them all at once. If you run them all at once, you see this. So now X label is values, Y label is frequency, and histogram that is easy. And you can always right click on this and save plot as. Yes, you can save it as whatever you want. And you can save it as PNG. So that was one example. However, as you can see right here, we have only, let's say, frequency is 1 for, so we have one observation that total score is really, really low. So and it's called outlier. Yes, an outlier is observation which is far below all other observations or far above all other observations. Let's say if we are talking about in a class and there are like 30 students, and then let's say if Bill Gates walks into that classroom and we are talking about income of people, obviously Bill Gates is going to be an outlier. Yes. So here, Sophia, whose total score is 348, observation index 7, is an outlier. Her total score is way below the bulk of observations. So we want to drop that observation, that row, and then redo this histogram. So let's create df2 in which we drop, or which means delete that observation. Remember, when you are dropping observations, you can just use df.drop. If you're dropping a column, you must say axis equals 1. So here, since it's observation, you can just say df.drop. Then I'm creating df2. I can ask Python to show me df2. And then if I take a look at this df2, I can see that I don't have index 7 anymore. Index 0, 1, 2, 3, 4, 5, 6, and then 7 is jumped. If I want to reset the index, I can say just this. df2 equals df2 dot reset underscore index. Drop equals true. And then take a look at this df one more time. And then now we are good. We don't have that gap in observation numbers. And we can do the same thing. Yes, we can do copy and paste everything we had and then do this histogram one more time. So this is just a histogram of what we had before. Yes. And you can see, for example, here we have more observations. Let's say here 8 observations, and then here, but we have 6 pins, and you can change everything. There are a lot of customization that you can do in Python. I'm not gonna get into details, but yes. So next one, for example, I want to do something like the same, but I want to focus only on male students. Yes, histogram for total only for male students. Can I do that? Obviously. All I got to do is, rather than df2 total, I got to say df2 in bracket, df2 gender equals m, and then total. And then everything else can be the same. And then just run this. Yes. And this is, let's say, histogram for total only for male students. Yes. Now, please, as a practice, do this. Question right now. So using df2, maybe do this. Plot a histogram for final for everybody. Yes. So here, using df2, plot a histogram for final exam. And then, so all I gotta do is to copy and paste here. And then, rather than total, I'll call it final. That's it. Yes. Let's do one more example. So plot a histogram. So using, let's say, df2, plot a histogram for, let's say, total. So we did that only for female students. So we did only for male. Please do this only for female students. Pause the video and please do this. Okay, I hope you have done everything correctly. All you gotta do is to copy and paste here. And then rather than M, you say F. That's it. Yes. So just run this. And yeah, that's a histogram for female students. Perfect. Let's move on. The next graph that we have is scatter plots. So a scatter plot uses dots to represent values for two different numerical variables with one variable on each axis. For example, I want to see, let's say, exam 1 versus final. First of all, you can customize figure size. Yes, Like the first number is width and the second one is height in inches. You can customize that always, yes. But I want to plot scatter plot of exam one versus final. So the syntax is gonna be something like this. PLT dot scatter, and then inside parentheses, variable 1, comma, variable 2. So this is the syntax, yes? Again, many of these, they are optional. Like this figure size, that's optional. And so just I'm going to select everything and then run all of them together. And I can see that the result is this. So here I'm saying that PLT figure fixed size 9 and 6. Again, we can always keep it that way or change it. Again, next first number 9 is width, the second one is height. Scatter df2 exam 1, that's the variable 1, which is going to be depicted on horizontal axis. Comma variable 2, which is right in this example is final, that's on the vertical axis. Then you can say, for example, color equals blue, color equals like red, and then the marker, like how you want each point to be represented. Here I am saying like with pluses. You can change that to, for example, letter O, different items, and you can have a title for your histogram, like scatter plot example, and I can call that, for example, I don't know, scatter plot example Azizi. Yes, and run that, and you can see that it's called scatter plot example Azizi. And then PLT X label exam 1, PLT Y label final. Essentially, that's it. So please, as an example, do this. Plot the scatter plot for exam 1 versus exam 2. Use color equals, let's say, red. So we want to make some change. And marker equals O. Okay, so I'm going to copy and paste everything here. I don't even need, so please stop the video, do it yourself. But I don't even need this first line, yes? So exam 1 versus exam 2. And then I'm going to change blue to red and this plus to just letter O. Then maybe this one, Y label, is going to be exam 2 as well. So I'm going to just select everything and run it. And I can see that I got exam 1 versus exam 2. And each dot is just one observation. So that's data visualization in Python. Next topic that we have is regression. Regression analysis is a type of data mining analysis which measures the impact of a set of variables on another variable. This another variable is called dependent variable, and these set of variables are called independent variables. So let's get to know this regression first before actually coding that. A regression is analysis of independent factors that influence a dependent. Let me make this bigger. Regression is the regression is an analysis of the independent factors that influence a dependent variable. So dependent variable is always just one. In the regression equation, we have this. On the left side, we have y. And then on the right side, we have beta 0 plus beta 1 times x. One, maybe it's more readable if I do this space, plus beta 2 times x2 plus blah blah plus beta k times xk. And then there's usually like a something called like u or error term at the end. But essentially, this is a regression equation. So on the left side, I have a variable called y, yes. And then on the right side, I have this x1 to xk, yes. So if that's a regression, let's see what we call this x1 to xk. They are called independent factors or independent variables. They're on the right side. You want to see the impact of them on, let's say, y. Y is your dependent variable. So there are many, many examples, but let's say, for example, y can be wage and x1 can be, let's say, education. X2 can be, for example, experience. X3 can be, for example, uh, age. X4 can be gender. Y is called dependent variable, and it's always just one. There's only one dependent variable. X1, X2 to xk, they are called independent variables. Yes. So we can have multiple independent variables, but we usually have only one dependent variable. We use a random sample, the data set, and Python to estimate the regression equation. Here we use regression for predictions. So in regression has many like different functionalities. Right now, I want to talk about the using regression for predictions. Yes. Okay. So the goal is to predict y given the values of x1, x2 to xk. So for example, if I give HW exam 1, exam 2, exam 3, I want someone to predict the final score for that student. Yes. Then using known, so how we do this prediction? First we y, first we regress y on x1, x2 to xk. So the verb is regress. And then we, using known values for x1, x2 to xk, we predict y. So two steps, yes? So step one is to regress y on x1, x2, xk. Step two is using known values of x1 to xk, predict y. Okay, let's do a few examples. Number one, the goal is to predict final given the values for HW exam 1, exam 2, and exam 3. So we want to predict what's going to be a final score for a student given their values for homework, exam 1, exam 2, exam 3. So two steps. Step one, regress homework on exam 1, exam 2, exam 3. How can we do that? We can, this is the code. OLS dot parentheses. Again, OLS means something special to us. Yes, it's a keyword. So OLS, here we said from statsmodel.formula.api import OLS. Yes, that actually means something to us. So that's oops, sorry, right here. Yeah, we say OLS, we open parentheses, and then when we open parentheses, we have, let's say, on the left side, the variable that we want to predict, final. And then we need this tilde sign. So tilde can be different on different keyboards. Mine is right below escape button, right above tab. So final, which is your dependent variable, tilde, HW plus exam 1 plus exam 2 plus exam 3. And then when you're done mentioning all the independent variables, you close that quotation marks, comma data equals data set that we have here is df dot fit. So if I want to write the syntax is going to be something like this. OLS, open the parentheses, and then quotation mark. On the left side, we have dependent variable. And then you need tilde, and then here you have, rather than independent variable 1, independent variable 2, I'm going to just write x1 plus x2 plus, so x1, x underscore 1 means x1, the first variable. X underscore 2 just means x2 plus all the way to the last independent variable that you have, xk. And then when you're done, you say comma data equals data frame name, whatever is that data frame is called. Then dot fit, and then parentheses. So that's the syntax that we have for a regression. Dependent variable is usually called y, so I can just replace that with y. So this is the syntax. And then usually you want to assign this to a name, yes, because we are going to use it later on. You want to call it whatever you want to call it, yes. Regression name, yes, choose a name. So you can call it banana, apple, peach, or I usually call them M1, and the next regression I want to run, I call it maybe M2, next one M3, whatever you want to have, but that's essentially the syntax that we have. So that's the syntax. Yes, the syntax for regression is very important. Just always keep that in mind, and then follow this. But essentially regression name. So here regression name is M1 equals OLS parentheses. Everything is going to be from beginning to the end of the equation must be enclosed in quotation mark. Final exam on the left side, tilde, and then all the independent variables separated by pluses. So HW plus, exam1 plus, exam2 plus, exam3. Then when you're done with mentioning all the independent variables, close that quotation marks, and then comma, and then data equals the name of your data frame, and then dot fits parentheses. So I'm going to run that. When you run that, just it runs, but no output would be produced. As an optional thing, you can just say m1.summary, and it's going to give us a big table like this that tells us how many observations we have, and then many, like a lot of information. So we have, for example, 29 observations. It tells us, let's say, R squared is 0.81, different things. It tells us coefficient for intercept, HW, exam 1, exam 2, exam 3, standard error, T, P, or P value, and then 95% confidence interval. We are not going to talk about them, however, so that's why I'm saying this is optional. Because here I want to just use regression only for prediction. So I ran that, so you can or run this, or you can skip this line, yes. Then I want to make a prediction. So when you want to, so that's step 2. When you want to do a prediction, you have to do a prediction for a specific, let's say, observation or person or object. So I want to predict the final exam for a student, hypothetical student, who got homework 1 as 185, exam 1 142, exam 2 131, exam 3 147. So these are all given in the question. So when you want to do this prediction, first you have to make a dictionary for that person, for this observation. Yes, for this observation, or for this hypothetical observation. Yes. for this object, whatever you want to call it. Yes. So how can I create a data frame? We have seen that in Python lesson 3, part A. So essentially you say pd.dataframe and D and F must be capital letter, open parentheses, and then pass in a dictionary. In that dictionary, column names must be exactly same column names that you have here in the same order. Yes, in that order. So I'm going to say HW again, because it's strings inside quotation mark, colon, and then all the objects, all the values in this dictionary, they must be in lists. So 185, but enclosed in brackets, comma, exam 1 in quotation marks, colon, 142 in brackets, comma, exam 2 in quotation marks, colon, 131 in brackets, and then last one, comma, exam 3 in quotation marks, colon, 174, and then you close curly bracket. That means you are done with mentioning the name of dictionary, and then you close parentheses. So here I'm just creating a dictionary. It has nothing to do with regression. I'm just creating this dictionary. It's called, so here I ask Python to display this dictionary for me. 100, so HW is 185, homework exam 1, 142, exam 2 is 131, exam 3 is 147. And then you want to do the prediction. So for the prediction, the format is this. The syntax is this. Regression name, dots, predicts, inside parentheses, the dictionary name. Dictionary name was A. So I'm going to say regression name is M1 dot predict inside parentheses dictionary name. So that's the syntax that we have. And if I run this, I can see that I predict this student, this hypothetical student, gets 344.079 on final exam. That's prediction. That student might get a better score or lower score, but that's our prediction. Okay, now pause the video now and answer this question. Predict final for student with HW 200, exam 1, 144, exam 2, 131, exam 3, 137. So pause the video now and solve this. Okay, hopefully you have done this correctly. Now, we don't have to do step 1. We only have to do step 2. So I'm going to just copy and paste this. You can call this A or you can call this something else. But HW rather than 140, 185 is going to be 200. Exam 1 is 144. Exam 2 is 131, the same. Exam 3 is 137. And then I run this. And I run this. And then I run this. So again, you don't have to ask Python to display A. I just do it to make sure I haven't done any mistakes. And then M1.predict A, 334.4. So my prediction is that that student gets this. Perfect. Let's keep going. In Python, Python has this ability, the capability that we can make some predictions for, let's say, 2 students at the same time. That's possible. So let's see how we can do that. For example, you want to prediction 2 observations at once. Predict the final exam for 2 students at once. First students got HW 185, 142, 131, 147, which is essentially the first students, yes? So we know that's 344. And then the second student, 200, 144, 131, 137, which is essentially we did it here. But rather than do it twice, we want to do it all at once. So essentially, you're going to create a data frame. You can call it A, you can call it B, you can call it banana, you can call it Dr. Surush Azizi, you can call it whatever you want. This B is just a name I chose for this data frame. Yes. So we are creating a data frame from a dictionary. Again, the name of these observations, the name of columns must be exactly in the same order that we have here, independent variables. So HW column, and then here when you are passing the list, mention all those two homework. So the first observation was 185, second observation is 200. So in the list, separate them with comma. Then exam one, colon, then 142, comma, 144. Exam two, 131, 131. Exam three, 147, 137. That's it. Close the curly bracket, close the parentheses. Now I created a dictionary, which I call it B, and this data frame. This data frame now has two observations, observation index 0 and observation index 1. So I asked Python to display this B for me, and I see that everything is done correctly. That's perfect. And then I asked Python to just run this predictions for me, and I can see that 344 is my predicted value for first observation, and 334 is the prediction for second observation or observation index 1. So, and they are exactly numbers that we got here. So 344 and 334, and we could just combine them, and we just did, and we got this. Perfect. Now, as a practice, please pause the video and do all of these yourself. So regress final only on homework and exam 2. What's the predicted final for students whose, let's say, homework is 180 and exam 2 is 140? And then make the following two predictions all at once. Student 1, homework 1, 180, homework 2, 140. Student 2, 170, and exam 2, 145. Yes. Pause the video, do all of these three questions at once. Perfect. Hopefully you have done everything correctly, and let's do this. So regress final only on homework and exam 2. So I'm going to say we can just copy this and paste it here. But here we have only on the right side homework and exam 2. So I'm going to get rid of this plus, and I'm going to get rid of exam 3. So that's all we have. So that's answer to first part. Then what's the predicted final for student whose homework is 180 and exam 2 is 140? For that, again, I can just do everything from beginning, or I can just copy and paste this. So that's more like my style. And then change. So there's no exam 1. I'm going to get rid of that part. There's no exam 3. I'm going to get rid of that part as well. Obviously, I do need the curly bracket and homework 1 and exam 2, but homework 1 is 180 rather than 185. So just say 180, and then exam 2 is 140. And then I also do this. So I run everything here. It's F9, F9, and then F9. So 341, that's the predicted value for this observation. Perfect. Now make the following two predictions all at once. Okay, again, I'm going to just copy and paste this code if I want to make predictions for two students, and then get rid of maybe homework 1, because now I'm regressing final only on homework and exam 2. So first student's homework is 180, and then second student homework is 170. Let's move on to exam 2. First student's 140, second student 145. Awesome. That's it. I'm going to just run this and this and then this. Perfect. Now, let's move on. Right now, we are wasting precious data. So when I did this, when I used final exam, when I regressed final exam on homework 1 and homework and exam 1, exam 2, exam 3, I didn't use gender. I didn't use year. Yes. We are wasting precious data. We have data on every student's gender. We have data on every student's year. Why we are not including them in a regression? Because they are not numerical columns. Yes, they are categorical columns that they take, let's say, strings. Gender was F or M. Year was freshman, sophomore, junior, senior. In regression, you must, if you want to include a variable, they must be numerical. So for many applications, such as regression, we must convert categorical variables to numerical. We have to convert everything to numbers. We'll do that usually by creating a dictionary. So let's take a look at this DF head. So DF head is something like this. So I want to convert M and F to numbers, and then freshman, sophomore, junior, senior to numbers as well. We do that with a dictionary. This dictionary, I just call it cleanup. You can call it other things as long as you have the same name right here, or you can just call them cleanup. So I say cleanup equals, then I open a dictionary, then it's a nested dictionary. What does that mean? So nested dictionary means that first, for example, I want to focus on column gender. I say, like, in quotation mark, gender, colon, and then for my value, the value itself is going to be a dictionary. And then inside that dictionary, I say F, again in quotation mark, colon 0. Pay attention, 0, which is a number, must not be enclosed in quotation. It must be number. So you should not have quotation mark around 0 or around 1 here. So I say F enclosed in quotation mark, colon 0, M enclosed in quotation mark, colon 1. And then comma, I'm done with the first part of this dictionary. Then second variable that I want to convert it to numerical variable is variable year. So I'm going to say comma, and then year in quotation mark, colon, and then I pass in as the value for dictionary, I pass in a dictionary. So it's going to be elements of this dictionary is going to be like here, the elements of this. So freshman, column 1, sophomore, column 2, junior, column 3, senior, column 4. And then I close this dictionary and I close the whole cleanup dictionary. So that's called cleanup. And by this, as a matter of fact, you can convert F to 0, M to 1, and then freshman to 1, sophomore to 2, junior to 3, and senior to 4. With this DF in place, DF replay, DF dot replace parentheses cleanup, and then comma in place equals true, because we want to make that change permanent. Yes. So with that, you can convert this DF. And if I run this DF one more time, DF head, now that you can see that variable gender takes 1 and 0. So whenever we had M, now it takes value 1. Whenever we had F, it has value 0. And here, year for freshman is 1, for sophomore is 2, for senior is 4, for junior is 3. And I can ask I can ask Python what's D types, and Python tells me that now gender and year, they are integers, yes, in int 64. Perfect. Now that we have done that, we can regress. We can use those two variables, gender and year, in the regression. How? Like this. I can say that, for example, I want to regress final on gender, year, and those variables that we had before, homework, exam 1, exam 2, exam 3. So step 1, the goal is to predict final given the values for gender, homework, gender, year, homework, exam 1, exam 2, exam 3. Perfect. How can I do that? Again, in 2 steps. This dictionary, I just call it M2. You can call it again, whatever you want. But on the right side, that's the important part. I start with OLS. I open the parentheses. Again, remember that syntax. Dependent variable on the left side, tilde, and then all the independent variables separated by plus. So I'm going to say gender plus year plus homework plus exam 1 plus exam 2 plus exam 3. When you're done with all of the independent variables, close the quotation mark, comma, data equals the name of data frame, which is df here, then dot fits parentheses. Just run that. And if you want, you can run this. This is optional. So you can make sure that you have done everything correctly. M2.summary parentheses. Now I want to do this. I want to predict, let's say, final for a junior male student with homework equals 200, exam 1, 134, exam 2, 139, exam 3, 137. So as before, I'm going to create a data frame from a dictionary. And in that, I'm going to say gender colon. Now, male was 1. Yes, remember here, male was 1. So gender 1, year 3, because the student is junior, homework 200, exam 1, 134, exam 2, 139, exam 3, 137. And then all I got to do is to run this. And then I ask Python to show me this data frame C, and I can see that everything is fine. It's a male student, junior male students. So male students in junior year, homework 1, 200, exam 1, 134, exam 2, 139, exam 3, 137. And then I can just say m2.predicts. See, and then it predicts that final exam for these students is going to be 340. Your predictions are going to be more accurate when you use like these two precious variables. Now, so let's do this yourself. Predict final for female freshman student with homework 160, exam 1, 124, exam 2, 136, exam 3, 150. Now, pause the video and do this yourself. Yes, please pause the video and do this yourself. Okay, hopefully you have done this correctly. But essentially, all you gotta do is to copy and paste here, this, and then change these. So gender is gonna be rather than 1, 0, because female was 0. The student is first year. Homework was 160. Exam 1 was 124. Exam 2 is 136. And exam 3 is 150. And then all you got to do is to run this. That's it. And we see that prediction is 332. Awesome. Let's do predictions for 2 observations at once. So let's say the first observation, let's do the same things that we had right there, yes? So here, maybe if I call it male junior, it's a better name because first you always want to say the gender and then students. But let's make these predictions for same two people. Yes, it doesn't have to be for the same two people. It can be for other people. Yes, let's do for other people. How about that? Female senior homework 195, exam 1 142, exam 2 130 131, exam 3 117. Student 2 male junior homework 200, exam 1 134, exam 2 139, exam 3 137. Now, you're going to make a dictionary exactly like this, but here the lists are going to be have two items. So again, each list, the first is going to be from student one. So gender, first one is female, year is going to be 4, exam homework is going to be 195 for the first student one, and then exam 2 is going to be, exam 1 is going to be 142, exam 2 is going to be 131, exam 3 is going to be 117. And after that, you put comma here, and then you mention like student 2. Student 2, gender is going to be 1, exam is going to be, year is going to be 3, homework is going to be 200, exam 1, 134, exam 2, 139, exam 3, 137. All I got to do is to run this. Then I'm going to ask Python to show me D. I want to make sure I've done everything correctly. Yes, I've done everything correctly. And then I say M2. Again, remember, name of this regression is M2, it's not M1 anymore. I run this, and I can see that Python generated predictions for these two observations. Awesome. Now, as a practice, please do this yourself. Regress final on gender, year, homework, exam 2. What's predicted final for female freshman whose homework is 180 and exam 2 is 140? Pause the video now and answer these two questions yourself. Okay, I hope you have done this correctly. I'm going to say M3 equals, then OLS, open the parentheses, quotation mark. Again, dependent variable is final. Dependent variable does not have to be final. It can be different things. Just in these examples, it's called final. Dependent variable final, tilde sign, and then on the right side, we have gender plus year plus homework plus exam 2. After that, comma, data equals df, and then after that, I say just dot fit, and that's it. That's M3. If you want to make a prediction, first you have to create this dictionary. I'm going to call this dictionary, let's say I used ABCD. Let's say I'm going to call this D2. Yes. D2 equals, and I'm going to create this dictionary. So PD dot data frame, parentheses, brackets, curly brackets. And then I have gender, which is, gender is female. Yes, so it's going to be 0, comma. Next one is year. Year is, the student is female freshman. So year oops, is 0, sorry, 1, comma. Next one is homework. So I'm going to say HW, colon, homework is 180. And then the last one is going to be exam 2. So it's going to be exam 2, and then colon, and exam 2 is 140. Yes. So I'm going to just run this, and then I say D2, and I created that everything correctly. Then I'm going to say M3 dot predict, and then D2. And if I run this, I see that predicted value is 356.1988. Perfect. Thank you very much, everybody, for listening, and I hope you liked this lesson. Thank you.